Hello and welcome back, everybody. Today we're going to be taking a look at how to complete the CASTER 3D solid model assembly. We're going to take a look at this document again, and we're going to take note of part 1, which is the post. Now this needs to be brought in first, so we need to bring these parts in to our assembly in the correct order, ascending order. So part 2, the bracket will be second, the shaft, part 3 will be third, the wheel, which is part 4, the wheel, will be fourth, and the bushing, etc., and the retaining ring we did not draw, except we will be including it in our assembly because we're going to be taking that from the Content Center in Inventor. So to get started, we're going to go into Inventor, click New, and select Metric Standard mm.iam assembly and hit Create. Wait for this to load up. To get started, we're going to go to Place, select Place, and scroll to the So I'm keeping these here in CASTER. So we're going to select part 1, which is the post. Zoom out a bit. We're going to say item number 2, which is the bracket. Right click, left click, enter to escape. Place. The shaft is third. Place the wheel. And lastly, the bushing. Now, I would like to change the finish on the bushing. This is something I didn't do when I created that 3D solid model. So what I'm going to do is just go back there, click on bushing, and go up to my material list and change this to brass, satin. Right here. Click Save. I'm going to close this off, and this should update my assembly, which it has. That's perfect. Okay, so we have all the pieces. We're going to start by creating a constraint from the center line of this bushing to the center axes of the wheel. And we're going to hit Apply. Next, we're going to create a constrainment, which is actually a flush. So we're going to select the bushing and then the wheel and then hit Apply. Next, we're going to position our bracket properly. So we're going to do what's called another mate. We're going to select the center axes here and here and hit Apply. Now, let's look at this from the front view. Now, what needs to happen is, because the width of this wheel is 28 millimeters and the distance between the inside faces of the bracket is 30, that's going to leave us with a difference of 1 millimeter. So what we can do is create another mate, but this time we're going to select offset. We're going to change that to 1. And what we're going to do is we can just free orbit this a bit. We can select the inside face of the bracket, turn it, and then this outside face of the wheel, and then hit Apply, and that should give us the perfect position for our bracket. This looks correct. We have equal distance on each side. That looks great. Okay, next up, we have to insert our shaft into the bracket. So what we can do with this is create kind of like a free rotate. So I just want to basically turn this and orient it into the position that I'm going to need. And I'm also going to do what's called a free move. I'm going to move it more to where it should be placed. Let's do that again. Move it. Okay. I want this to insert the correct way, right? That rib needs to insert into the side of the bracket where the keyway is. So what we're going to do is select, constrain the center axes of the shaft to the center axes of the bracket, the bushing, and the wheel, and click apply. All right, so that gets it started. Now we want that rib to be flush with the key. So the side of the rib must be flush with the side of the key, the same side of the keyway. So according to our iPad sheet that I'm looking at next to my computer, the key in the bracket is 2.5 millimeters wide and the rib is 2 millimeters wide. So that's going to leave us a difference of 0.25. So what we're going to want to do is create a flush with an offset. So we're going to turn this, we're going to go to constrain, and we're going to remove the zeros and we're going to type decimal 25. Then we're going to select the side of the rib, spin this around, and find the side of the key, and then hit apply. Now, it doesn't look like anything has happened, but that constraint is very subtle, so it's something very important. We're basically straightening up that rib to the keyway when we do that. So next up, spin this around again. We're going to select this face and this face of the bracket and create a mate and apply it. Right, so that should be in the correct position now. So we're just spinning this around, taking a look at it. Everything looks so far so good. And lastly, we have to insert the post. So what I'm going to do is another free rotate. I'm going to rotate this into the correct orientation. I'm going to grab a free move. I'm going to move it up top like this. Find a constraint. Place constraint. I'm going to pick the center axes and the center axes here. And hit apply. I'm going to pull this up a bit. What I need to do is create another constraint. We're going to make this, actually, I'm sorry. Pull that up again. It's this surface we want to make. So the peen diameter sits inside the bracket. So we're going to go constrain, select this surface and this surface and hit apply. Okay. So now everything should be correct. Alright, so last thing is to place the external series retaining ring, which is noted at size 5133. Okay, so we're going to go to place. We're going to go to place from content center now. And we're going to go into shaft parts, circlips, external. And we're going to find the circlip that we need or something close to it. Now, I've already gone through the clips in the content center, and I'm unable to find part 5133. So the one that we're going to use a metric key, retaining clip for sure, we're going to use this one, 3673 Part 4 metric. We're going to select it. We're going to hit OK. And how this is going to work is we're going to select this groove diameter first. Then we're going to turn this a little more, just enough, so we can find this face that's closest to the large chamfer on the shaft. And once I've done that, I'm ready to drop the clip in, but I can hit change size. I really don't want to change the size, but it just goes to show you that, okay, this is close enough. It shows the groove diameter at 6.7, even though ours is 6.4, so 0.3 millimeters. And that outside shaft diameter for us is 7.5, but it does not give a size between 7 and 8, so it's defaulting to 7. So this is fine for us. So we're just going to hit OK, and that's going to drop that clip right in for us. All right, so now we're retaining the shaft to the assembly, so the shaft won't slip out. Everything is being held appropriately. Remember, I called this a key earlier. It's not. It's an external series retaining ring, just to correct myself. It gives a little bit of play here, which is fine. And the last thing we need to do with this is save it. So we're going to go to File, Save As. I'm going to change to where I'm saving my stuff here. CASTER 3D Models, and we're going to change the name simply to CASTER and select Save. Okay, so now I have it saved up, and I'm ready to create my drawing file, my assembly drawing file next. So try this, right? Make sure you get your parts assembled correctly. Make sure you bring the parts in correct ascending order like you see here. This is important because this is going to make sure our parts list in our drawing file is set up in correct ascending numerical order. So that means that part 6, the retaining ring, will naturally be at the end. So good luck. I'm sure you'll do great, and I will talk to you soon. Take care.